Hello students, welcome to today's session. So today we will be discussing about the nomenclature of Spiro compounds. So what exactly are the Spiro compounds? The nomenclature is quite easy. Spiro compounds are the compounds in which two cycles are joined to each other through one bridgehead atom. Unlike bicyclo where you have two bridgehead atoms, here in Spiro compounds, just the way I am showing you. Say for example, if this is one cycle and another cycle is this, say for example. So this is the bridgehead atom in this. So we will be referring this as bridgehead atom. And the nature of this bridgehead atom would be quaternary. This is a quaternary carbon which is joined to four carbon atoms. Quaternary carbon atom. So unlike the bicyclo where we talked about bicyclo, in the bicyclo you have two bridgehead atoms, just like the way I am showing it here, and you refer to the bicyclo compounds as well. So this is a compound which we are referring to as Spiro compound. Spiro compound is a compound, two cycles are joined to each other through common bridgehead atom, and from that bridgehead atom two cycles are being drawn on each of the direction. Now how to name it? Naming is quite easy. As long as there is no substitution, the naming is quite easy. You have to write first Spiro, then you have to place the square bracket. Now what you have to see into it, that if I would move from this side to this side, how many carbon atom did I get? I got two carbon atoms here. And if I would move from this direction to this direction, I got 1, 2, 3. So I got 3 carbon atoms. So here, unlike the bicyclo, here you have to write it in the increasing order. In this path, moving from this direction to this direction, I obtained 2 carbon atoms. So I would write 2 dot, and here I got 3 carbon atoms. In totality, how many carbons I have counted? 5. And 1 is of the bridgehead. So it is Spiro 2,3 hexane, because there is no double or triple bond here. So this is what you call it as a Spiro compound. And for the bicyclo, you refer to the separate video which is already there in the playlist. Similarly, let us take one more example. Here, this is the bridgehead atom. This is the bridgehead atom. And in this bridgehead atom, if I would move from this direction to this direction, I obtained 3 carbon atoms, 1, 2, 3. And if I would go from this direction to this direction, I obtained 1, 2, 3, 4, 5. So here I have 5 carbon atoms. So the naming is very easy. Spiro, square brackets, ascend. You have to write it in the number of carbon atoms, the length of the carbon atoms in a ascending order. So it is here it is 3.5. So 3 and 5, 8, and 1 is the bridgehead. So it is nonene. So very simple, not a very difficult one. And moving on further, if I would write for this one, so it would be Spiro, and you could see very well here you have 2 carbon atoms. So 2, this side also you have 2 carbon atoms, 2. So it is pentane. And as a matter of fact, this would be said as to be the smallest in the homologous series of Spiro hydrocarbons. It is the smallest Spiro hydrocarbon, isn't it? And the formula for this would be C5H8, because it is having 2 rings. So the degree of unsaturation would be 2 here in this case. So as long as the story is very easy, as long as there is no substitution or any attachment of function group, the things are very easy. You have to write the Spiro. You have to select that chain which is having a lesser number of carbon atoms than the bigger chain, number it, and then lastly you count the total number of carbon atoms and correspondingly write the alk for that. And if there is no double and triple bond, so you would be writing as alkane. So it is spiroalkanes. Now coming on to the, if in case it is containing some functional group, if it is containing, say for example, if I would write a Spiro compound of this nature, and I just would place, let's say I just have placed one OH group here. Now how to number it? This is very, very important. So the numbering in case of Spiro compounds would start from carbon atom next to bridgehead atom. Here you would not see into the fact what we generally do in the conventional naming. So here the numbering has a new set of rule which you have to adopt. So numbering would start from a carbon next to bridgehead. Now next to bridgehead you have 4 carbon atoms because the bridgehead carbon is quaternary. So I have 1, 2, 3, 4. There are 4 carbon atoms next to the bridgehead. This is your bridgehead, which I am marking it with pink, and the yellow dots I am referring to the carbon atoms next to the bridgehead. But which one is to be selected? Next to bridgehead, present in the smaller ring. Present in the smaller ring. You have to start the numbering from the carbon next to bridgehead in the smaller ring, irrespective of the presence of any function group, and then thereafter you have to go to the bigger ring. So here how I have to number it now. So this is the bridgehead atom which I have marked it with pink, and you have to now number it. So we would be starting the numbering next to the bridgehead is this 1, 2, 3, and then this is 4. Now you can go this way also, 5, 6, 7, then OH would get a 7th position, but we would want to keep OH at a smaller number. So it would be 5, 6, 7, 8. Again, the story is not very difficult, very easy it is. So what would be its name? So we shall be writing Spiro, then square brackets. So in this square bracket, how many carbon atom did I have? Moving from this side to this side. So I have with me 1, 2, 3. There are 3 carbon atoms here. On this direction, 1, 2, 3, 4, 4. So in total 7, and 1 is the bridgehead. So it is heptane, heptane, heptane. But on the 6th position, you have the presence of ol, that is the alcohol. So it starts with suffix of the OH is having vowel O, so this E get omitted. So the name of this compound happens to become Spiro 3,4 heptane 6-ol. Not very difficult, very easy. Let us take one more example. So here the bridgehead atom, here the bridgehead atom is this one, and you have to start your numbering next to the bridgehead in the smaller ring. So I can start from here 1 or from here. Obviously I would start from the methyl part because it should be given the least number, because if there is possibility I should give it a least number. 1, 2, 3, then 4, and this is 5, 6, 7, 8. Simple, not a very difficult one. So it is almost exactly the same or almost the same. In the previous case it was 6-ol, here it is on the 5. So we shall be naming it as Spiro. So here again you have 1, 2, 3, and here you have 1, 2, 3, 4. So Spiro 3,4 octane 5-ol, and we are left with methyl part which will be treated as a substituent. So 1 methyl would come at the start. So this is the name of this compound, not a very difficult one. So coming on to the next one, here you have again the smallest ring on this side, 1, 2, 3. So should I go this way, 4, 5, 6 or 4, 5? So obviously I should go from the lower side. So here it would be 4, 5, 6, 7. Now here you have a function group which we call it as CHO, which has a suffix as ul. This ul would be used as a suffix when the carbon of CHO is included in the main carbon chain. If you have this CHO, this is the general conventional suffix of it, ul, but this ul would be used when the carbon of CHO would be in the main chain. Because it is not in the main chain, I cannot take it in the main chain. So it would be referred to as with a new suffix which we call it as carbaldehyde. For this I would refer you to see into the special important latest rule of IUPAC for which I have already made an video. So now the name of this compound would be Spiro. So here you have 2 carbon atoms. Here you have 1, 2, 3, 4. In total is 7. It is hept. Hept means there are 7 carbon atoms and there is no presence of no double or triple bond. So it is ane, heptane, and lastly you would also write 5 carbaldehyde. and what else we are left with is the presence of bromo, that is 1 bromo, which is to be treated as a prefix. So this is the name of this particular compound. So the story is not so difficult, it is quite easy. Coming further, here what you have, this is the bridgehead atom. Here again you start with a smaller 1, 2, 3, and then comes the 4, and this is 5, 6, 7, 8, 9. So here, what is this? This is thioether, or as a matter of fact, O stands for ether. When such groups are there in the cyclic ring, you cannot use their journal names. So here a special name would be given. As I am going to write, first I should write it here. So it would be treated as Spiro. For this also I have already made an video for the special naming where the conventional naming would not work for a given function group. So here Spiro, it would be 3 because there are 3 carbon atoms. Then 1, 2, 3, 4, 5. I counted sulfur as carbon and would let you know what should I say for this. Spiro 3, 5. In totality you have 8 and 1 is the bridgehead, 9. So it is nonane. But actually it is not nonane. Non means 9 carbon atom. But on the 5th carbon you have a prefix called as thia. Just like in the earlier videos I have already said it somewhere. This is named as thia, and if there is a ether it would be said as oxa. So make it a point, these are 2 important statements which you have to keep it in mind. And I just would refer this that you should go through that replacement nomenclature for which already the video is being there in the playlist. The smallest Spiro hydrocarbon of a formula this would have the value x plus y as how much? So we, in the video itself, we wrote somewhere that C5H8, for which the degree of unsaturation had been 2, that is 2 rings are there which constitute 1 degree, which would provide 1 degree of unsaturation. So here you have, this is the smallest one because the smallest of all ring is 3 carbon, and 3 carbon is to be joined with 3 carbons so that it could become Spiro. So the formula of this compound is C5H8. You can see it here very well. So this is the carbon for which there is, and this is CH2, CH2, CH2 and CH2. So as a matter of fact, so you have C5H8, 8 plus 5, it happens to come out to be 13. And the number of secondary carbon atoms in the above compound would be, this also is a very simple thing. This is a secondary carbon because it is attached to 2 carbon atoms. A secondary carbon is a carbon which is attached to 2 carbons. So this is attached to 2 carbons. And similarly, this also is secondary, this also is secondary, and this also is secondary carbon. So there are 4 carbon atoms which are of the nature of secondary, and 1 carbon which is quaternary is of the bridgehead carbon, that is quaternary in nature. Based on this particular question, you may be asked a question like this also. Smallest Spiro hydrocarbon, you have to identify the smallest Spiro hydrocarbon having all the carbon atoms, primary, secondary, tertiary, quaternary carbon atoms would exist in how many isomeric forms. So you need to first make a Spiro compounds which would contain all the set of, but it is to be smallest. So which way we should go for? So first I would write this ring, and obviously when I write this becomes secondary, this also is secondary, and from here you have to start 1 ring so that this would become a quaternary or a Spiro, bridgehead atom of the Spiro. So this becomes quaternary. Now still I have to place secondary is covered, quaternary is covered, and we have to bring in tertiary. So tertiary, how could I generate a tertiary one? If I just would place 1 carbon here, CH3, in a way, if I do so, what shall I get here? This would become tertiary because now it is joined to 3 carbon atoms, and this becomes primary. Why methyl is primary? Because it is attached to only 1 carbon, that is this one. And if I just would join these together, so this is secondary, this is secondary. I think almost everything has been covered. Let me write it once again for you. So I drawn a structure of this nature. and placed a methyl group here. So if somebody would ask you, this is primary, this carbon is tertiary because it is attached to 3 carbon atoms, 1, 2 and 1 of the methyl carbon. So it is tertiary. This is secondary, and this is quaternary, and this is secondary, and this is secondary. So I presume, or I feel as if that it is the smallest hydrocarbon containing all set of primary, secondary, tertiary and quaternary carbon atom. So how many isomeric forms? So I think it is, I do see here that there is only one isomeric form, because if somebody would do this way, because all these positions are chemically identical, wherever you place one methyl, if you place one methyl, these two are same, or if you would place one methyl here, this also is same. So it would have only one isomeric form. Moving ahead, let us place one more question. How many Spiro compounds can be formed from this formula? So this I would give you as a homework. Do comment, do write on to the comment section how many isomeric forms you would get for C6H10. You need to make it as a Spiro compound. Hope so that you have understood Spiro well and seen the application of Spiro compounds, that how small questions can be asked from this particular topic in terms of nomenclature as well as in terms of the isomeric forms. Thanks a lot. Have a nice day. Stay safe and take good care of yourself.